Translation moves the object to the left or the right. It may go up and down to a different height. The last one is enlargement, and to do it just right, the center of enlargement is the first thing to sight. But knowing the scale factor, draw the image, it might be larger or smaller despite the word enlargement. Reflections, flip over in the mirror, rotations, spin around the center, translations, move up or down and sideways, enlargements get bigger or smaller.
Well, welcome back, geometry students. This is our last transformation to talk about in 4.5 here of our big ideas geometry called dilations. That song was using the word enlargements, but we call it dilations here in this chapter. An enlargement typically means it gets larger, but enlargement, you know, it's saying it could go either bigger or smaller. Enlargements can get bigger or smaller. So we call them dilations, which means dilations can get bigger or it can get smaller. The figure changes its shape that way. So that's what we're going to be doing. We're going to identify and perform dilations in this one. We'll look at some real life problems by the end. First, let's take a look at a little cartoon here. So I got Superman here say, "What? It's my Halloween costume." Very funny, Robin. So apparently Robin dressed up as Superman just to take Batman off, I guess. I don't know. But here we go with our dilations, our core concept right here. Now on page 114, you're seeing this. So we talking about dilations. This is a dilation is a transformation in which a figure is enlarged or reduced. So we're enlarging or reducing. Those are the two things we can do to our figure with respect to a fixed point called C, and that would be the center of dilation. So the center of dilation is just a fixed point at which you can dilate, and a scale factor. So we're going to do it by add a fixed point and also a scale factor, which is what we will enlarge it by. So you could see here our figure. This is kind of what it looked like even on that little song video. So you have your original right here in blue, your P, and then you got your P prime up here. Here's your new figure. It got bigger, it enlarged. If we went this way, we would reduce. So this one is got an enlarged, it's an enlargement. So a dilation with center of dilation C and scale factor K maps every point P in a figure to the P prime, where all of this is true here. So if P is the center, if P is the center point C, so we got center point C, then P equals P prime right there. So right here, this equals this right here. So that's what we're talking about. These will equal each other. If P is not the center point, so P would be in the center between these two, then the image of P prime lies on C to P. So it lies on this ray right here. So that the scale factor K is a positive number, so our scale factor is the one we're going to be looking for. Typically they tell us what the scale factor is, but you could actually find the scale factor with multiplying, from C right here to P prime and then over CP. Alright, so let's take a look at a couple of examples. That will make a whole lot more sense when we actually see the example for this. So let's take a look at this. It's not to write down. You don't need to write these paper clips down or safety pins down, but basically it just says find the scale factor, tell whether it's a reduction or an enlargement. So for this first one, A, you can see from C to P prime, that's 12. C to P is 8, and that's what this was saying back here. We're going to find scale factor K. That's what we're going to be calling our scale factor, is the K. But we want to put that segment over the other segment. So the C to P prime over C to P. So that's what we're doing on this one. So it's going to be 12 over 8, as we could see that. So it's 12 over 8, which we can reduce that here. So K is a 3 over 2. That's our scale factor, is 3 over 2. Or we could even do a 1.5 there. And you can see right here, how do you know it's an enlargement? Well, look at where P is. P is the smaller. Here, P is your original, P prime is the new one. So the original is smaller than the new one, so it got bigger. That's how you could tell. For this one, our C to P prime right here, so here's C to P prime, it's smaller, is 18. So that's going to be 18 over c to p, which is 30. And so you could see 18 over 30 would reduce to 3/5. It is a reduction. You could see that the original is bigger and the new one is smaller here on the diagram. Also, another way you can also tell is just by looking at the scale factor. If your scale factor is more than 1, it's going to be an enlargement. If the scale factor is less than 1, it is a reduction. All right, so on page 115, our first 3 problems here is basically the same thing there with those paper clips. Find the scale factor of the dilation, then tell whether the dilation is a reduction or an enlargement. So this is why we don't just call these enlargements, because enlargement just seems to imply that it's just going to get larger all the time. So that's why we do call them dilations. So I like the word dilation a little bit better because that could go back or forth. It could get bigger or it could get smaller with a dilation. It could be a reduction or an enlargement. So we're going to need to find the scale factor first. To do that, that's the K. We want to do this here, C over P prime. We're going to put that segment on top and then the CP on the bottom. So basically the C to C prime, that would be the new figure. So that's your new figure. So if you want to think of it this way as well as the fraction, the new one is on top and the original one is on the bottom. So that's what the C to P prime is talking about over CP. Same idea. So if we look at this first one, number 1, we're going to go C to P prime. That's this part right here. So we want to see, okay, well what is that? We don't see what that is. We see what this is here. We see the whole thing is 4. So that means if this is 2 and this whole thing is 4, then this is also 2 as well. So it's going to be 2 for that. And then for this C to P, it's 4. So it is going to be 2/4. So our C to P prime is just 2. And C to P is 4. The entire thing's 4. And so we reduce that, and our scale factor is a 1/2. And then we want to see, okay, is it an enlargement or a dilation? You could kind of tell that because your original one is bigger, your new one is smaller. So that would definitely be a reduction on that one. All right, so for number 2 and 3, I'm going to go ahead and just try these two. So go ahead and do these two the same way. Figure out what the scale factor is, and then just write down whether it's a reduction or an enlargement. So go ahead and pause the video and do 2 and 3. All right, so hopefully you've done these two. You got the scale factor, and you also wrote down if it's an enlargement or a reduction. So for number 2, our C to P prime, that's all the way down here to the corner, is 25. C to P is 20. So it's going to be 25 over 20, which we reduce here. We want to reduce that by 5 on top and bottom. So that's going to be 5/4 for our scale factor, which is more than 1, so it should be an enlargement, which it is, because the original here is smaller, the new one is going to be the bigger one. So that's definitely an enlargement. Number 3, our C to P prime, that's going to be from all the way out to here, so that's 27. So it's 27 over C to P, which is 9. So 27 over 9, we reduce that, that's actually going to be just a number right there, which is 3. So our scale factor is 3. We don't need to say 3 over 1, we can just say 3. And so since that's definitely more than 1 and our original is the smaller one, the new one is bigger here, that's definitely an enlargement. All right, let's move on to our next part. Okay, so at the top of 115, so just right above there, you'll see the rule for dilations. It's the coordinate rule. Now, we had coordinate rules for reflections and rotations. We do have a coordinate rule for dilations. We do, however, need to know what the scale factor is. So here is the coordinate rule right here. You may want to highlight this part of this because it's right here. The coordinate rule is here. How do you find the new points like P prime? It is this right here. But first, you need to realize that it's going to be centered. The center of dilation is at the origin. So this only really works when center of dilation is at the origin. Just like the other rules, we're always at the origin as well. So, or the rotation was anyways. So the scale factor is going to be multiplying your x and your y. Scale factor here is k. So whatever that scale factor was, like on that last one, number 3, the scale factor was 3. So it would just be 3x and 3y. So you just know how to plug in your x and y, multiply it by 3 to get your new points. Okay, so here's a couple you don't need to write these down. I just wanted to show you how we would get this coordinate rule. So here's your vertices. Here's the points that we have to change. And it says it's the scale factor for the dilation is 2, so that means we're going to multiply 2 times the x and times the y. So our rule is this right here. Here's the rule, 2x comma 2y. We would just plug in our numbers like 2 times 2 is 4, 1 times 2 is 2. On this next one here, you can see this says the scale factor is 1/3. So you can multiply the x and the y by 1/3. So it could be like this, 1/3 times x, 1/3 times y. Now when your scale factor is a fraction like this, if it's just a 1 over a number, it might be easier to actually divide by 3, because we could do this. We could put x on the top and say x divided by 3, y divided by 3, and that would work. So I sometimes just do that. That makes it a little bit easier, I think. So if I say, well, this number divided by 3 would be -1, 6 divided by 3 would be 2. Just seems to be a little quicker. On this next one, it's a -1/2. So our rule for this one, we want to multiply this times x and y. So it's a -1/2 times x, -1/2 times y. That's the coordinate rule. But again, since 1's on the top, you can put the x and the y on the top and just say, okay, it's going to be negative x over 2. So you're going to divide it by 2, but make it negative y over 2, and so on. So it's like this one right here. You plug that in, -4. You're going to change its sign and divide it by 2. That's going to be just +2 then for that one. All right, let's go ahead and try some now. All right, so here on problem number 4, it says graph the polygon. So we're given A, B, and C. It's going to be a triangle. So we're going to plot those points and graph the polygon and its image after the dilation with a scale factor of k. It tells us that k equals 2 on this one. Let's go ahead and plot these points. So A is at -3, and let's look at our coordinate plane. Every box is worth 1 here. So -3 and 1, that's going to be up here, -3, 1. I'll label it A. Third quadrant for B, -4, -1, right down here. And then also third quadrant for C, -2, -1, right down in here, -2, -1 right there. So we're going to just connect our dots. So connect our dots, make our triangle, and now we want to see, okay, our scale factor is 2, so that means we're going to multiply every x and y in here by 2. So this is our rule here, 2x, comma 2y. And we can just plug these numbers in for x, multiplying by 2, and the y is multiplying by 2. So for A prime, so we want to do A prime point, so it's going to be -3 times 2, which is going to give us -6 for that x point. And then 1 goes in here. 2 times 1 is 2, so there's our A prime point. For B prime, we're going to multiply, take -4, plug it in here. 2 times -4 is going to give us -8. And take the -1, put it here. 2 times -1 is -2. And for C prime, so -2 times 2, it's -4. And -1 times 2 is -2. So here's our new points for our image. We're going to plot each of these, and that will be our dilation. So A prime is -6, 2, right over here. -6 up 2 in that second quadrant. -8, -2 in the third quadrant way over here. And we got -4, -2 for C prime, -4, -2 here. And then let's again just connect all the dots together to make our triangle. There it is. And you can see it's an enlargement. It got larger here. Scale factor was 2, which is more than 1, which means it's going to be an enlargement. Okay, so number 5 on the top of 116, we'll do the same thing. Let's plot these points, P, Q, R, and S. 4 points, which means we're going to have a quadrilateral in this one. So again, every box is worth just 1. So -10 and 0, that's going to be right there on the x-axis, there on the left. -5 and 0 is also on the x-axis right there. And then 0, 5, that's on the y-axis right up here for R. And then -5 and 5 is in the second quadrant right here, left 5 and up 5. And let's just go ahead and connect the points there. That actually makes a parallelogram, is what this shape is called, a parallelogram. Both sides are parallel here. Then the scale factor says that k is a 1/5. So if it's a 1/5, that means we can just divide by 5. So we can put the x over 5 and the y over 5, if you want to do it that way, or 1/5 times x. But it's the same thing as saying x divided by 5 and y divided by 5. So I like writing the rule like this. X over 5, y over 5, and then I'm going to plug in my points here to make my prime points for the image. So our P prime point here, when I do this one, -10 goes over here. -10 divided by 5, that's going to give us -2. And then for 0, 0 divided by 5 is still 0. And then for the Q prime point, negative 5 divided by 5 is negative 1. And then also 0 divided by 5 is 0 again. For R prime, we start with 0. 0 over 5 is still 0. And then 5 over 5 is positive 1. And for the S prime point, they're both 5s here. Negative 5 over 5 is negative 1. And positive 5 over 5 is positive 1. And now we just plot these points here. So negative 2, 0. Right here on the x-axis, we're going to have negative 1 and 0 just right next to it. There for Q prime. 0, 1 on the y-axis right up here. And negative 1, 1 right there in that second quadrant. Again, just connect your dots. It should be the same shape of that. It just got smaller. It's a reduction. So our original one is bigger and the new one here is smaller. So it was a reduction for this one. Scale factor is less than 1, so definitely a reduction. All right, let's take a little quick break for our joke of the day. So why do ghosts make good cheerleaders? Answer: because they have a lot of spirit. Of course, they must have a lot of spirit. Okay, so back there on 116, number 6 and 7 says find the coordinates of the image of the polygon after a dilation with the scale factor k. So this is exactly the same as basically 4 and 5 we're doing, except we don't have to graph them. We just want to come up with the points. That's all we got to do. So I'm going to let you do these, number 6 and 7. Go ahead and pause the video and come up with those points. Use the scale factor there to come up with those points. I'll just give you a little hint on number 7. A point, this could also be changed to a fraction of a 1/4, a negative 1/4 for that one as well. All right, so go and pause the video and do 6 and 7. All right, so hopefully you've now just trying to check your answers to see did you get these ordered pairs correctly for our image for the A prime, B prime, and C prime. For this one on number 6, our scale factor is negative 6, which means to multiply your x and y by negative 6. So negative 6x, negative 6y. So if when we do our A prime point here, so negative 3, negative 6 times negative 3 would be a positive 18. And then 1 for the y, negative 6 times 1 is negative 6. So there's our A prime. For B prime, negative 4 goes here, so negative 6 times negative 4 is positive 24. And then negative 1 going in here again. Actually, not again, sorry, it's just a 1. That was 1 there. Now it's negative 1, so negative 6 times negative 1 is positive 6. And then for C prime, negative 2 going here, negative 6 times negative 2. That's going to be positive 12. And then for negative 1, same as this one, it's going to be 6 for that one as well. So there's your points. You should have got those right. If you missed, did anything wrong, just fix that on your paper. Number 7, so we said that this could be a 1/4, a negative 1/4, which means if that's a 1 on the top, then I could divide by negative 4, basically, is what I could think about doing. I could divide by negative 4, which means my rule could be like this: x over negative 4, y over negative 4. And I can then just plug in my points for the p prime and so on. So for p prime, we're starting with negative 8. Negative 8 divided by negative 4 is positive 2. And then 4 goes in for y. 4 divided by negative 4 is negative 1. For q prime, 20 goes in for x. So 20 divided by negative 4. That's going to be negative 5. And for negative 8 here divided by negative 4 is positive 2. For r prime, 16 divided by negative 4, that's going to give us negative 4, that first one, and then 4 divided by negative 4 is negative 1. And for the last one, s prime, 0 divided by anything is still 0. So that's still going to be 0. So if it's 0 here, it's going to be 0 here when you divide by it, or even multiply by it. 12 divided by negative 4 is negative 3. All right, so there you go. Make sure you checked your work and you got the right ordered pairs. And if you need to fix something, go ahead and fix that. All right, let's go on to a couple real-life scenarios now. So this first one is about a photo. So we've done this before. Maybe you wanted to enlarge a photo, make it bigger, or you could even try to make it smaller as well. In that case, sometimes that happens. You take a big picture and you want to make it smaller. So it says you're making your own photo stickers. Okay, so we want to make it smaller then. Your photo is 4 inches by 4 inches. That's your original photo right here. The image on the sticker is 1.1 inches by 1.1 inches. All right, so that's what we needed to get to. We need to go from 4 inches down to 1.1. So what is the scale factor of this dilation? So our original here is 4 inches and our new one is 1.1. So you can see what they're doing there. Remember, it's always the new one over the original. And that's what we talked about before. It's the new over the original, 1.1 inches over 4 inches. So our scale factor as a fraction would be 11 over 40 because we wouldn't want a decimal inside of a fraction. Move the decimal place 1 over here to make 11, add a 0 to the bottom. So 11 over 40, which is less than 1, is our scale factor. All right, so there on number 8 on page 116 says you design a poster on an 8.5 inch by 11 inch paper for a contest at your school. So that's just a normal size piece of paper there. The poster of the winner will be printed on a 34 inch by 44 inch canvas to be displayed. What is the scale factor of this dilation? So we're making it larger, it's an enlargement. So our original piece of paper is like this, 8.5 by 11. The new one, so the image or the enlargement is going to be like this, 34 inches by 44 inches on the canvas. And so to figure out what is the scale factor of this dilation, remember the scale factor is K, we can call it K, but it's the new side length over an original side length. You just got to look at a side length, the corresponding side length really. So you wouldn't put 8.5 or 8.5 over 44, those don't correspond. The 11 is the longer side of this one, it's going to correspond to the longer side on this one. So we could put 11 over 44 here, so our K could be 11, new side length is 44, so 44 is going to be over 11. So it's always new, which the new one is the canvas here, which is bigger, 44 goes on top, original is 11, that's going on the bottom. So now we can see 44 over 11 would simplify to just 4. So that is our scale factor. 4 is the scale factor of this problem. Okay, here's another one, a creepy crawler, a little spider. It says, you are using a magnifying glass that shows the image of an object that is 6 times the object's actual size. So determine the length of the image of the spider seen through the magnifying glass. So right here it's 1.5 centimeters is your spider. So again, image length over actual length, that's what you can think of. So the image is the new one, the actual one is the original. So you can always find the scale factor that way, image over actual. So our image we don't know, but the actual length we do know, it's a 1.5. It just shows us right here, this is the actual length. And it says that we're trying to make it 6 times the object's actual size. So your scale factor is 6 on this one. So we're not asked to find the scale factor. It tells us that it's 6 times. We're multiplying it by 6. What we're trying to figure out here is the actual, basically how much, what's the length of it in the image. How much, what would the length be in the magnifying glass. So we just want to, solve this, multiply both sides by 1.5. And that would just give us 9. So 6 times 1.5 here to solve for x would be 9. So the image length through the magnifying glass is 9 centimeters. All right, so our last problem here, number 9, a biology book shows the image of an object or an insect that is 10 times its actual size. So that 10 times is a very important number there. 10 times, that's going to be our scale factor. The image of the insect is 8 centimeters long. So you can look at the book, you can measure the book and see that it's 8 centimeters long. What's the actual length of the insect? So again, the way we figure this out is that the scale factor is equal to the image length over the actual length. So the image length over actual length is equal to the scale factor, which we know K here. K is 10. We also know the image length, which is 8. What we're trying to figure out is the actual length. So when we actually do our numbers now, so we know the image length, which is 8. That's going to go on top. The actual length we don't know, which will be our variable, our unknown. And we do know the scale factor K on this one is 10. And so here on this one, what we can do is multiply first both sides by x to get rid of the fraction. So when we do that, now it just becomes 8 equals 10x. Then we can divide both sides by 10 to get x by itself. So when we divide both sides by 10, the 10's cancel here. 8 over 10 can reduce to 4/5. But we want an answer in a decimal form on this one. We don't just want to say 4/5. So 4/5 is the same thing as 8/10 or 0.8. So we would just say 0.8 centimeters on this one. So the actual length of the insect is 0.8 centimeters if it's 8 centimeters long on the book. All right, so that concludes our 4.5 lesson on dilations, and I'll see you on the next lesson.